To do this calculation, you use the ionic equation for 1 mole of the acid, base, or salt. You write the first step towards this calculation. Write the ionization equation for 1 mole of the acid. Write the ionization equation for 1 mole of the acid or base or salt, assuming the acid given is H2SO4. The acid given in the reaction is H2SO4. The ionization equation will be H plus SO4 2 minus. Your first step is write the ionization equation for 1 mole of the acid, base, or salt. Step 2. Step 2. This is step 1. Step 2. Use the ionization equation for 1 mole of the acid, base, salt to express the number of ions in terms of number of moles. Use the ionization equation to express the number of ions in terms of mole. What do I mean by this? This one is, you want to express it in terms of mole. 1 mole of H2SO4 giving us 2 mole of H plus 1 mole of SO4 2 minus. Step 2, you use the ionization equation for 1 mole of the acid to express the number of ions in terms of number of moles, as I've just done. Step 3, use the ionization equation to express the number of ions in terms of Avogadro constant. Use the ionization equation for 1 mole of the acid, base, salt to express the number of ions in terms of Avogadro constant. What do I mean by that? For H2SO4, we have H plus 2 plus SO4. This is what is relevant to us. This is 1 mole of acid. In terms of mole, 2 moles of H plus. And when you are expressing the number of ions in terms of Avogadro constant, you have 1 mole of acid giving you 2 moles times 6.02 times 10 raised to the power 23 number of ions or molecules. Then the last step now, step 4. For the last step, you are now going to use the ionization equation in terms of the Avogadro constant. This one, ionization equation in terms of Avogadro constant. We are going to use it as reference standard to calculate our number of ions or molecules that is contained in 1 dm cube of solution. That is Ca in 1 dm cube. Let's look at an example. We want to look at the calculations involving number of ions now. Example. We want to look at an example. A is 6.3 gram per dm cube of HNO3. B is Na2CO3. Volume of acid is 20.50. Volume of base is 25 cm cube. The equation for the reaction is 2 HNO3 plus Na2CO3 giving us 2 NaNO3 plus CO2 plus H2O. The examiner says 1. Calculate concentration in mole per dm cube of B. Concentration in gram per dm cube of B. 3. Number of sodium ion number of sodium ions in 1 dm cube of B. Four, volume of A in dm cube. Volume of A in dm cube. That will produce 0.5 mole of NaNO3 in solution. So the answer now. Concentration of B in mole per dm cube. B is sodium triisocarbonate. So you using CaVa over our Ca, concentration in gram per dm cube of Ca, concentration in gram per dm cube of the HNO3 acid, which is solution A, is given. So we can calculate the concentration in mole per dm cube using concentration in gram per dm cube over molar mass. And that is 6.3. The molar mass of HNO3 is 63. And we have 0.1 mole per dm cube. So let's substitute into Cb. Our Ca is 0.1 multiplied by volume. The given volume is 20.50 multiplied by Nb. Our Nb in the equation is 1 multiplied by 1 over our Vb is 25 multiplied by Na. Our Na is 2. What is the answer? The answer is 0.041 mole per dm cube. What is the concentration in gram per dm cube of B? Concentration in gram per dm cube of B. That is concentration in mole per dm cube multiplied by molar mass. The molar mass of B, that is sodium triisocarbonate, is 106. The concentration in mole per dm cube of B is 0.041 multiplied by 106. And the answer is 4.35 gram per dm cube. Now we want to calculate the number of sodium ion in solution. To calculate the number of sodium ion in 1 dm cube of solution B that contain 0.041 mole. We want to calculate the number of sodium ion in 1 dm cube of solution B that contain 0.01 mole using the ionization equation for 1 mole of Na2CO3. What's the ionization equation for 1 mole of Na2CO3? That is Na2CO3 given us Na2, giving us 2 moles. So this is 1 mole. 1 mole of sodium triisocarbonate, giving us, in terms of Avogadro constant, 2 moles times 6.02 times 10 raised to about 23. Therefore, 0.041 mole of NaCO3 in 1 dm cube will give us 2 times 6.02 times 10 raised to about 23 over 1 times 0.041. And the answer is 0.49 times 10 raised to about 23. To know the number of sodium ions, we write the ionization equation for 1 mole of sodium triosocarbonate. And then we express the number of ions in terms of Avogadro constant, as I've just done. You express the number of ions in terms of Avogadro constant. And you now use this as reference standard to do your calculation. So that is the number of sodium ion. The last one. Volume of A in dm cube. Volume of A in dm cube that will produce 0. Let's use the stoichiometric equation for this reaction. In the equation, we have HNO3, 2 mole of HNO3, giving us 2 mole of sodium triosonitrate. We are using sodium triosonitrate to calculate the HNO3. So it's going to be 2NaNO3, giving us 2HNO3. Therefore, the 0.5 mole that is produced, therefore, 2 moles is giving us 2 moles. Therefore, 0.5 mole of sodium triosonitrate will give us 0.5 mole of HNO3. So we now find the 0.5 mole. We now find the corresponding volume of 0.5 mole of HNO3. We now find the corresponding volume of HNO3. What is the concentration of HNO3? Concentration in mole per dm cube calculated for the HNO3 is 0.1. If 0.1 mole of HNO3 is contain 1 dm cube. Therefore, 0.5 mole of HNO3 will contain 1 over 0.1 times 0.5 equal to 5 dm cube.